The KFA GTX 980 Hall of Fame Edition, the fastest GTX 980 that we've ever benchmarked. Let's take a look. Alright, so while we unbox this, let's go over the specs for this card because it's kind of monstrous. Alright, so out of the box, this is a GTX 980, which of course means that it's 2048 CUDA cores. Now this one is overclocked out of the box, and what that means is the base clock is 1304, 1.3 gigahertz, and the boost clock is 1418, 1.4 gigahertz. Now, with our own overclocking beyond that, we were able to hit 1500 megahertz, 1.5 gigahertz. That's crazy on the boost clock. Now, the memory configuration, of course, is 4 gigabytes, the same as all GTX 980s, and the memory speed is 7 gigahertz out of the box. The connectors is you got a DVI-I, which is, of course, dual-link DVI, DVI, or DVI-I for analog. It's got HDMI, that's HDMI 2.0, so you can do 60 hertz of 4K with that. And then it's got a luxurious 3 DisplayPort 1.2 ports, PCI Express 3.0. Is the interface. It's comes with a DVD install guide, user manual, 8-pin power adapter, and of course a DVI to VGA adapter. But if you're using the DVI to VGA adapter with this, that's very sad. You should not do that. This thing will power 4 displays simultaneously, so they don't mess around. You know, you could use the dual link DVI or the HDMI, and then all 3 DisplayPort ports, and that would be completely fine with this particular adapter. Now, in terms of new technologies this thing supports, it's the Nvidia Dynamic Super Resolution, Nvidia Global Illumination, GameWorks, GameStream, 4-way SLI. You can run that with this. DirectX 12. This is a DirectX 12 card. We do have DirectX 12 benchmarks in this video, so woohoo. Nvidia Shield Ready, G-Sync Ready, GPU Boost 2.0, Nvidia Adaptive Vertical Sync. Those are all the supported technologies. Now, Dynamic Super Resolution was one that I had not heard of before, but it turns out what this does is if you got a 1080p display, it'll actually render the game or whatever you're doing at 4K and then downsample it to 1080p. 4K is still kind of slow on cards unless you've got a lot of these. So unless you're playing a source engine game, you're not going to be, 4K. 4K is okay. Some of our benchmarks, 30 hertz, older games, things like that, but we'll get more into that when we get to the benchmarking section. So it's a cool feature, but I'm not really sure how practical that particular thing is. That said, let's take a look at the card. So taking this thing out of the box, it is massive and weighty. So yeah, this thing packs some serious punch to it. This is a triple slot card. Don't let the back plate fool you. If you've got a motherboard that arranges the slots and you're going to run this in SLI, you would not be able to run this unless you've got 3 slots between the slots that you would run in SLI. The cooler is very large. I like that they've done that though, only putting in a dual slot backplate, because that means that it'll work in a lot of ITX cases that don't actually have a triple slot cutout. So like the Fractal Node 304, for example, this will fit just barely in a Fractal Node 304, so that you can run this, even though this is a triple wide card, it'll still fit in that ITX case if that's the situation that you happen to be in. Now this does of course take 2 8-pin power connectors. The GTX 980 is one of the most power thirsty cards from Nvidia ever, and especially if you're going to be overclocking this. So it's going to drink the power and it's going to put out a ton of heat. I do feel like I need to bring up something about the way that this card exhausts heat. It's not anything bad. It's actually sort of good, but it's something you'll have to pay attention to when you mount this in your case. So this draws air in where the fans are, and it exhausts the heat along the top of the card. So depending on how you've got this card set up in your case, if you have a fan on the side of your case that is blowing into the case, make sure it is blowing below the card and not on the card, because if it's blowing on the card, if it's blowing on the edge of the card, it's going to be fighting with the fans that are in this particular GPU to cool it. And so when we were testing it, we weren't really paying attention to that, and the numbers that we were getting while benchmarking were kind of warm, and so it turned out actually moving the side door fan down just a little bit so that it was blowing fresh air in to be taken in by the built-in fans on the video card. That worked way better because the hot air was coming out the edge of the graphics card. Now the cooling situation on this card is monstrous, as you might imagine, with the overclocks that it sort of pushes out of the box. It has 3 fans, 2 80mm fans and 1 90mm fan. The heat sink on this is sort of split into 2 pieces that are connected by heat pipes. And so there's actually 4 8mm heat pipes and 3 6mm heat pipes. That's a total of 7 heat pipes on this for cooling. The large central fan sort of sits in between the 2 large heat sinks that are connected by heat pipes. Now, of course, it's got cooling for the VRM assembly. You can see that that's bolted through on the back, and you can see that most of the heat sink is really toward cooling the GPU. Now, as I mentioned about the way that it exhausts heat, because of that design, it doesn't really exhaust any heat at the back, and it really couldn't, because there are only 2 small holes at the back. Pretty much the entire back is taken up by display connectors, and then the overclock button that's at the back. Now, of course, it does have the customizable top Hall of Fame LED. You can control that from the GeForce Experience. That's pretty cool. I played with that. You can make it pulse and all the standard stuff in the GeForce Experience. Now, a stock GTX 980 is about 36 degrees C at idle and about 83 degrees under load. This thing in testing was anywhere from 28 to 32 degrees idle, and under load it was anywhere from 68 to 73. That's really good considering that we were running with the stock configuration, which is the 1418 boost clock. So this thing can really dump a lot of heat into the environment around it. So you've got to make sure that the case that you put it in, or however you're going to run this, can deal with the amount of heat that this thing dumps into the environment. So keep that in mind. These Hall of Fame edition cards have some other unique features. The button at the back, they call it the Hyper Boost technology. Basically, it's just a hardware turbocharger. You can toggle on and off the overclock settings and the over voltage settings. It'll let you, when you toggle the switch on, it'll let you push the voltage and some other parameters just a little bit further than you would ordinarily be able to. This power delivery circuitry, it's an IR 3595. That's a digital PWM. It's got twice the switching frequency of the previous generation. That's an 8+2 power phase design, and it can deliver up to 60 amps. The coils on this are premium Coiltronics high current copper power inductors, and it also has aerospace grade power inductors. They call it the aerospace grade GALAX extreme power inductors. It does have a hardware dual BIOS. There's a little switch underneath the heatsink that you can reach with your finger, and that'll let you toggle between an A and a B BIOS. So with all the FreeSync, G-Sync stuff floating around, chances are your graphics card's going to need a BIOS update to deal with that. So you've got an A and a B BIOS. There's no risk of breaking your card if something goes wrong with the flashing the BIOS. If you're an experimenter or an enthusiast, there are different versions of the BIOS out there that will let you access more lower level features on the card, so you can flash different BIOSes on your graphics card. And having the A and the B switch means that you can recover from that situation if you do something wrong. Although I really wouldn't advise you to mess too much with that unless you really know what you're doing and don't mind messing with the card in a way that the manufacturers perhaps did not intend. This is a white PCB. That's a 10-layer PCB. It's a custom PCB. It's totally redesigned from the ground up for the GM204, and it has an optimized layout that is supposed to deliver a cleaner signal and have a higher signal to noise ratio. It does have a really awesome anodized aluminum backplate. The thing is great. It's spaced a little bit off the PCB. It seems to be able to let the PCB breathe. I was really worried that the backplate was going to trap in the heat, but it seems like they did a really good job engineering it so that the backplate would not really interfere with the cooling of the card. It does get warm, it does get toasty, but it seems to actually help distribute the heat and carry it away from the card a little better. Now for our benchmark system, we're going to be using the ASRock X99 WS 10 gig. This is the system that we happen to have on the test bench at the moment because we're doing some shots with 10 gigabit Ethernet and a Netgear switch and some other stuff. So that's just what we had. It's got 16 gigabytes of crucial memory in it right now and a 5960X Intel i7. And so that's what we're going to be using with all the benchmarks and all the results and everything like that. It came from that platform. So, all right, without further ado, let's take a look at the benchmarks. Benchmarking. Now, this is just going to be a quick overview. I'm not going to bore you guys by reading a whole bunch of numbers. The full results are on the website. So if you want to see the full results, you want to see the actual everything, which is pretty comprehensive, check out the website. We did 4K testing with the Dell UP2414Q. That's an IPS 4K display with DisplayPort 1.2 And this was the KFA2 GTX 980 HOF 347.88, Windows 8.1 Enterprise x64. We also tested Windows 10, but that's coming up. GPU benchmarks. All right, so we went over the stock and boost clocks. The FireStrike performance was 12,753, which is pretty good. This is this part you can just go for the website because it's just charts and graphs. I'm going to show you some of the more anomalous things. So you guys probably seen the PC Perspective DirectX 12 benchmark, which is really interesting. They had a GTX 980 and a GTX 960 that they overclocked, and so with the overclock on the GTX 960, like a 33% overclock was a little less than a 66 performance bump, and it's like, I wonder if that's because it's a dual core. There's like 2 compute cores. That's one of the things that Nvidia has said. So we overclocked the bejesus out of this thing. It's factory overclocked out of the box, but we overclocked it even more than that. We got the RAM speed for the DirectX 12 benchmark up to 8 gigahertz. So BIOSHOCK Infinite 1080p, about 120 frames a second across the board. It dips down to about 60 frames per second, but yeah, basically 120 frames a second across the board. At 2160p, that's 4K, about 40 frames a second, give or take. We did the CUDA computations. The device time for the pi calculation was about 34 seconds. OpenCL was about 32 seconds. System configuration for Windows 10 is the same. Windows Pro x64 build 10041. 12784 again on the FireStrike, so that's good. Windows 10 hasn't done anything terrible to wreck the performance, at least in this case. BIOSHOCK Infinite, 120 frames a second across the board, 40 frames a second at 2160p, blah, blah, blah. Not really 34 seconds versus 30 seconds, so a little bit better on OpenCL. We've got the LuxBall 2 results. It's a 27,111, so, and that was at 1418. And then we got the Sala benchmark as well. It's 3579. Premiere Pro benchmark. The time to encode H.264 timeline was 95 seconds. This is there's a link to this on the website. This is just a Premiere Pro like productivity benchmark. It's pretty neat. It's not one that you see very much, but we often get a lot of questions like, "Hey, how does this actually work with the Creative Cloud stuff?" By and large, After Effects is CPU bound. There are some effects in After Effects that can be GPU accelerated, but Premiere Pro is really the thing that helps you a whole bunch with your GPU will help you a bunch with your acceleration in Premiere Pro. So this is a Premiere Pro benchmark. And so here we are in our 3D Mark API overhead comparison at 1450 and a 2 gigahertz memory clock. That's a quad pumped, so it's really 8 billion transfers per second. It's pretty fast. We sort of see an increase here on the 3D Mark API overhead, as one would expect, with the increasing overclock. Now for DirectX 11, we don't really see that. And DirectX 11 multi-threaded, we don't really see that. But with DirectX 12 and the overclock, we actually see a pretty steady increase. But we do not see like a dramatic increase the way that PC Perspective saw it with the 960. Now this is a 980, so it's a little different. See, the 960 has 2 compute cores and the 980 has 4 compute cores. And so if overclocking the 960 by 33% produced, it was a 57% increase in this benchmark. If the fact that there were 2 compute cores working both at a 33% overclock, and 57 is kind of close to 66%. So with this thing with 4 compute cores, would we see a 33% overclock result in a 133% increase? And the answer is no, we don't. So GPU benchmark Windows 8 versus Windows 10. So this is sort of a comparison. All right, so FireStrike Extreme, and FireStrike Ultra, basically the same. It's a little bit of a performance improvement in Windows 10 across the board. BIOSHOCK Infinite, Windows 8 versus Windows 10, basically identical. Windows 10 is maybe a little slower. It's interesting, 1080p. 1440p, or not 1440p, 2160p. Gotta get on the habit of saying 2160p. Windows 8 and Windows 10 are basically identical performance, but now Windows 10 is just maybe a little bit ahead of Windows 8 at 4K. Interesting. Okay, Starswarm. This one is the really weird one. Now, Starswarm can take advantage of DirectX 12, so that's why we put it in here. We've got Windows 8 versus Windows 10. All right, so the average batch count, Windows 8 22,195 versus 2572 on Windows 10. Don't know what that means. This is 1080p, but 2160p. So we have basically we just skipped to the end, the average batch count. We've almost doubled the average batch count between Windows 8.1 and Windows 10 on Starswarm at 4K. Now supposedly Starswarm is DirectX 12. I'm pretty sure it was running at DirectX 12. We just sort of ran through the benchmarks really quickly. This maybe merits further investigation and follow-up in a future video. Now, just a quick note about branding. We're taking a look. This is the KFA GTX 980 Hall of Fame edition. KFA or GALAX, it's the same company. It's just a different name depending on where you are on planet Earth. And so the name in America is different than the name in Europe. And so this was sort of a merger thing that happened a little while ago. And so if you see this and it's like, wait, the box says GALAX and not KFA2, it just depends on what part of the world that you're in. This is the KFA2 that we're taking a look at, but it's the same card from GALAX, so it's the same company, just so you know. Alright, well that's been a quick look at the KFA2 GTX 980, the fastest GTX 980 that we've benchmarked to date. We're going to be using this card for some upcoming tests with G-Sync, and we're going to be using this card for some upcoming 4K benchmarks. So stay tuned for that. If you have any questions or there's anything we missed, or you got one of these and you really like it, or there's something that you want to ask us a question about, head over to the forums at techsyndicate.com. We'll see you there.